A Chinese processor built on an instruction set most engineers have never shipped a product with just reportedly ran a 100 billion parameter artificial intelligence model. That is the kind of workload everyone assumed required ARM or x86 infrastructure. The dominant ecosystems behind virtually every serious server and artificial intelligence chip on the planet. The processor is the C950, developed under the Huygens and Zhuangtai lineage. The instruction set is RISC-V, and the reason that matters has almost nothing to do with the benchmark. Before you dismiss this as a claim about an obscure academic architecture, the performance detail is one data point, and it's an unverified one. The real story is why China is staking its entire processor future on this architecture at all. Because if RISC-V becomes the foundation for China's artificial intelligence and server compute, it removes the single most reliable lever the United States has ever held over Chinese chip development: the ability to revoke a license. By the time you understand how that mechanism actually works, the framing shifts entirely. This is not a story about an obscure instruction set. It is about what happens when one side figures out how to build a lock that cannot be picked from the outside. So why RISC-V? There are three answers, and only one of them is actually true. The first answer is the one you hear most often. RISC-V is free. No licensing fees, no royalty agreements, no ongoing payments to a third party. That is accurate. It is also completely insufficient as an explanation. Countries do not bet their national processor roadmap on an immature software ecosystem just to avoid a license bill. Saving on rent does not explain why you built your house on a different continent. There has to be a bigger reason. The second answer goes a level deeper. Avoid dependence on ARM and x86, both of which are controlled by companies domiciled in the United States or subject to United States influence. That is also true, and it is closer to the real story. But it still does not complete it. You could reduce dependence on those architectures without committing to an underdog instruction set with a fraction of the software ecosystem. Avoidance alone does not explain the bet. The real answer runs through something that happened to Huawei in 2019. When the United States added Huawei to the entity list, ARM's license to Huawei became subject to review. The license was not permanently revoked, but it was temporarily complicated and placed under government scrutiny in a way that made the dependency unmistakably visible. ARM is a United Kingdom domiciled company with deep United States technology content in its supply chain and corporate structure. That means any licensing relationship with a Chinese chipmaker runs through a set of legal and regulatory relationships the United States government can reach. The same is true of x86. Intel and AMD are United States companies subject to United States export controls, and their instruction set architecture is not something you can implement without a licensing relationship tied to that legal reality. Can China just negotiate ARM licenses like everyone else? They did, until the political environment made that negotiability a liability rather than a solution. Any license that can be negotiated can be unnegotiated. And that is the vulnerability that no amount of engineering investment can fix so long as the underlying architecture belongs to someone else. So what does RISC-V actually change? RISC-V International, the body that governs the specification, is incorporated in Switzerland. It is a non-profit. The specification itself is published openly under a Creative Commons license. There is no royalty. There is no license agreement between RISC-V International and any chip designer. You read the published document, you implement it, and you own your implementation. No United States entity can issue a revocation because there is nothing to revoke. The specification already exists. It is already public. It cannot be unpublished. Think of it this way. A proprietary instruction set architecture is a key that one company cuts and controls. They can duplicate it, restrict it, or take it back. RISC-V is a lock design published in a library. Anyone can read it, anyone can build from it, and there is no key to confiscate. The argument, and it is a structural argument, not a settled legal ruling, is that United States export controls can restrict Chinese participation in the governance body, but they cannot reach the specification itself because it is not a licensable property controlled by any United States entity. The document is already in the world. That distinction is the entire bet. Now bring the C950 back into focus. Haigan and Xuantai's C950 is among the most prominent RISC-V server and artificial intelligence processor efforts in China. The reported claim that it ran a 100 billion parameter model is significant not because it proves competitive performance with leading ARM or x86 server chips, but because of what that scale of workload actually demands. Running a model at that parameter count requires on the order of hundreds of gigabytes of memory at standard precision. For context, the original GPT-3 had 175 billion parameters. Getting anywhere near that range requires substantial memory bandwidth, coherent multi-core execution, and a software stack, compilers, runtimes, model frameworks, that functions reliably on the instruction set. Think of it as asking a chip to coordinate the memory equivalent of several hundred high-end gaming machines, all communicating with each other, all running the same enormous calculation in lockstep. If that reportedly works on RISC-V, the software stack is further along than most outside observers had assumed. But here is what the bullish version of this story consistently skips. That performance claim is reported, it is company adjacent. It has not been independently benchmarked or publicly peer-reviewed based on available record. Treat it as evidence of direction, not confirmed benchmark. And even setting the claim status aside, the software ecosystem around RISC-V for high-performance compute is genuinely less mature than what exists for x86 or ARM. Compilers, operating system support, artificial intelligence framework optimizations, and production toolchains took decades to mature on the incumbent architectures. Linux kernel support for RISC-V has been mainlined, and major artificial intelligence frameworks have partial RISC-V support. But partial is the operative word. The gaps are real, they are documented in the technical community, and they represent a genuine near-term drag on adoption. So why make the bet now rather than a decade ago? Because a decade ago, the stack was nowhere near a usable threshold. The RISC-V specification was first published around 2010 by researchers at UC Berkeley. It has matured steadily since, but it only crossed the line from academically interesting to productively usable for serious workloads relatively recently. China is making this bet now because the foundation became buildable, not because it became complete. And that distinction matters for how you evaluate the limitation. If your vulnerability is a thin software ecosystem, that is a solvable problem. You can invest in it. You can mandate it. You can build the missing tooling with sustained effort and time. But if your vulnerability is a revocable license held by a foreign company subject to another government's export controls, no amount of engineering investment removes it. That structural gap cannot be closed by writing better code. RISC-V does not close the ecosystem gap, but it removes the one vulnerability that was structurally unresolvable. This also does not exist in isolation. It fits a pattern that has been building for years. China systematically attempting to move its technology stack beneath the layer where external leverage operates. The push toward domestic electronic design automation tools, the investment in SMIC at mature process nodes, and now the commitment to RISC-V at the instruction set level. Each step is an attempt to lower the floor of dependency. RISC-V is simply the most structurally complete version of that attempt, because the specification cannot be revoked by any government on Earth. Here is my honest read. The triumphalist version of this story says China has already secured its processor future. That is not what the evidence shows. The ecosystem gaps are real, and a single reported benchmark from a processor whose production status has not been publicly confirmed at scale, is not a platform. The dismissive version says RISC-V is too immature to matter strategically. That also misreads the situation. Maturity is a gap you close with time and money. Unrevocability is a property you either have or you do not. The reading that actually fits the evidence. China has identified the one layer of the stack where the rules of the sanctions game do not apply, and it is building from there. Whether that foundation holds the weight of everything that still needs to go on top of it, the compilers, the frameworks, the models, the production volume, that is the question the next several years will answer. Every licensing choke point the United States ever held over Chinese chip development had a keyhole. Instruction set architecture licensing was the deepest one. RISC-V removes the keyhole. The lock cannot be picked from the outside, not because China built better security, but because there is no lock to pick at all. So here is what I want your honest read on, in the comments. Is the unrevocable foundation worth a decade of ecosystem immaturity? Or does that decade cost China more ground than the structural immunity gains? Two genuinely defensible positions. I want to know which one you would stake money on, and why. If you want to follow how this specific bet resolves, when independent benchmarks arrive, when the software stack either closes the gap or does not, and what that means for the next round of controls, subscribe, because that is exactly what this channel covers. A chip built on a spec anyone can read, reportedly running a model nobody expected it to run. The lock is unpickable. The only question is, what gets built behind it?